A child was struck by a car at a bus stop. The driver of the car had slammed on his brakes and left skid marks 160 feet long. He told police he had been driving at 30 miles per hour. The police know that the length of skid marks varies directly as the square of the speed of the car. Let's stop our reading and focus on the sentence at the beginning of the second paragraph. Police know that the length of the skid, so this is the subject, and that it varies, that is our verb, directly, that is the relationship, as the square, we're going to need to use that as part of our model, of the speed. So let me translate all this into a math model. So step one is to define the variables that I'm going to use. The first variable I'm going to use is L, and L is the length of the skid mark. The next variable I'm going to use is S, and S is the speed. My second step is to set up an equation to model the relationship. So I'm going to start with L because it comes first in my sentence. And then my verb, varies, will be represented with the equal sign, which is always followed by K. It's a direct variation, so it's going to be multiplied by the speed, and the speed is squared. So I have a model for all of the information that was in the sentence. My third step is to find K. So I'm going to need a length and a speed that I know go together. The temptation is to use the one that I already read in the opening paragraph. There was skid marks 160 feet and there was a speed of 30. However, the speed may or may not be true because the speed wasn't measured, it was told to the police. So instead I want to look down here in the second paragraph about what police know. And we are told given that at 30 miles per hour, under similar conditions, skid marks would be 40 feet long. This is the pair of numbers that we want to put in to find K. And then we're asked how fast was the driver actually going. So my guess is that police at the scene are guessing that he has not told the truth, that his speed was 30, because 30 corresponds with a 40-foot long skid mark. So I'm going to my equation. Length of the skid mark is 40. K is unknown. That's what I'm trying to find. And the speed that we're working with is 30, and that gets squared as part of my equation. So I need to solve this. So 40 is equal to K times 900, which is what I get from squaring 30. Then I'll divide both sides by 900. And I get my K value. Now my K value in fraction form would be 4 over 90. And that's the exact value, which could simplify to 2 over 45. But I'm just simplifying easily here, canceling out a 0. In decimal form, this is 0.04, and then the 4 repeats. The less you round this, the better your answer will be. But if you round this a bit, your answer will have a little bit more variation to it. So you can decide how you want to round, and it'll change your answer just a tiny bit at the end. So fourth and final step is to solve the question. So the question is, how fast was the driver actually going before he applied brakes? So we want to know the speed. We know that at the scene of the accident, the skid marks were 160 feet. We know K is this 4 over 90, or you could use that as a decimal approximation. And we don't know speed, and we have that squared. So in order to solve this, we're going to try to get the S by itself. So I'll divide both sides by my constant of K. And that'll give me the speed squared is equal to 3 Now, if you rounded a bit on K and used the decimal, you might have here 3636 as the number, and that'll be fine. As I said, with this particular one, I didn't give you directions how to round, so it's open to interpretation. Now, we haven't done any equations like this yet, but if we think it through, we can figure it out. This is squared. So the opposite of squared is square root. So I want to take the square root on both sides. The square root of 3,600 is 60. The square root of s squared, square root and squared cancel, just like multiply and divide cancel each other, so that's s. So this would say that his speed is 60 miles per hour. And depending on how you round it, you could get up to 63. So anywhere in that 60 to 63 mile per hour range, based on your rounding, would be a correct answer. So definitely what he told the police that he was going 30 is not the truth. And we see from the scene of the crash, the evidence points that he was going much faster.